So in this problem, we're told that in the rest frame, the mean lifetimes of muons is 2.20 microseconds. And in the frame in which the muons are moving, the mean lifetime is given by 16.0 microseconds. And we're asked to calculate the speed with which they are moving. So we've seen that we can use the time dilation formula for this, as in the rest frame, the muons are at rest. So we can use our formula that tau is equal to tau naught over the square root of 1 minus u squared on c squared. So let's rearrange this. We have the square root of 1 minus u squared on c squared is equal to tau naught over tau, and so we can square both sides. So when we do that, we will get rid of this square root here, and we will square this side, and so we can write this as u squared on c squared, moving this term over to this side and this one over to this side, is equal to 1 minus tau naught on tau squared. So u squared is equal to c squared times 1 minus this, and so this tells us that, well, u is equal to c times the square root of 1 minus, and at this point we can substitute in. So let's substitute into this equation up here. So u is equal to c times the square root of 1 minus 2.2 microseconds over 16 microseconds squared. There's microseconds on the top and the bottom, so we don't need to worry about our factors of 10 to the minus 6. They will cancel each other out. So this is equal to 0.9905 times c. That c's that c, and that's just putting this into the calculator, which we can write as 0.991 c to 3 significant figures. C's the speed of light, so it's got units in the c. Okay, so we're now interested in the muons frame, how far can they travel? So in muons frame, the distance they travel is going to be equal to the speed times the time. So the speed that they're traveling with is the 0.9905 c, and the time they live for in their frame is 2 times 10 to the minus 6 seconds. So solving this, we end up with 613 meters. So in the muons reference frame, they can travel 613 meters. So this begs the question, if there's 10 kilometers between the upper atmosphere and the surface of the Earth, how are the muons making it down? I mean, this is the how long one with a normal half-life can travel. So presumably if you have half-lives lifetimes a little bit longer than this, but it doesn't explain how many of them can make it through. So in the muons frame, the length appears contracted. So the length in the muons frame is equal to the rest length, which is length in the Earth's frame, minus times the square root of 1 minus u squared on c squared. The length in the Earth's frame, we're told, is 10 kilometers. So this is times 1 minus 0.9905 squared c squared on c squared. And so solving this, we end up with 1,375 meters. So in the muons frame, it looks like the distance from the upper atmosphere to the surface of the Earth is 1,375 meters, which is a lot less than 10,000 meters. And so this is about double what they can travel in a normal lifetime. But because some of them live longer, some of them live shorter, some of them will make it to the surface of the Earth in this frame when they're traveling this quickly.